All right, so last week, this is where we left off. We had talked about the total revenue test. And so the total revenue test was looking at determining total revenue at two particular points. And I know I have it up there, but what is total revenue? What does that mean?
Total revenue.
So how much money the producer is going to make from selling it. And so last week we talked about you have to find the total revenue by multiplying price times quantity at 2 points. So this is the last screen you saw last week. And we found that point A, we were multiplying 25 times 5 to get 125, and point B, we're multiplying 20 times 15 to get up to 300. And from A to B, our price went down, our total expenditure went up, so therefore this was an elastic demand curve, okay? So I wanted to start here to remind us where we were, because today I am going to give you practice in doing this, and you're going to have some that are elastic, and so I wanted to make sure that we kind of briefly reviewed the elastic, what this looks like. Okay, so does anybody have any questions about what an elastic demand curve looks like? Yeah, no. Good? Okay, so today we're looking at inelastic and unit elastic. So to start off with, remember this one, okay, this is just continuous, you don't have to write that one part, okay? So we're on 2. Just reminding you that we're still talking about the total revenue test. So inelastic is going to be where the total revenue and the price are directly related between 2 points. Okay? Remember from the last slide, elastic is where total revenue and price were indirectly related. Now we have total revenue and price are directly related between 2 points. So just like the last slide, I have a graph for you, just like last week. I will remind you, I would highly recommend you draw it, okay? So I'll show it to you in just a second. But keep in mind, okay, that we are still looking at total revenue at 2 specific points on our demand curve. Okay, so we're still just picking out 2 points on our demand curve. We're still finding the total revenue. So here's what our inelastic demand curve is going to look like. Okay, what do you notice about the difference between this demand curve and the one from the last slide? Just the way I drew it. It's steeper, right? In an elastic demand curve, so the last slide, it was much more horizontal. It was almost laying flat. In an inelastic demand curve, it's almost vertical. So when you're drawing this in your notes, make sure you're drawing it correctly. So don't just draw a straight diagonal line and try and make it inelastic, okay? You have to draw it this way for it to be accurate, okay? So again, we're going to take price, 2 points. We're going to take first point A, and then point B, and you will notice that, okay, all I did was I literally copied and pasted this graph from the last slide, okay? So what you'll find is the prices are the same, but you will find is that the quantity has changed, okay, because this is demand inelastic, okay? So first of all, at point A, we still have a price of $25, okay? So whatever this item is, it's going to cost $25, just like the last slide. And the quantity at point A is going to be 5. So we're going to say at point A, 5 people were buying, just like the last one. So to figure out our total revenue at point A, we're taking 25 times 5. So our total revenue at point A is going to be 125. 5 times 25 is 125. So total revenue at point A should be TR. Need to change that, sorry. TR is going to be 125. So total revenue is 125 at point A. Now, at point B, okay, at point B, we're saying that the price is $20. So just like the last slide, you'll notice that the difference, the space between the $20 price, the $25 price, it is the exact same as the last slide, okay? The only thing that has changed is we changed the slope of the line, okay? So as a result, okay, point B, guess what? Our quantity only went up by 1, okay? 6 people were willing to buy this product at $20. So it still follows the law of demand. We still had a price drop. We still had an increase in quantity. But in this case, our increase in quantity was very low. So $20 times 6 will give our total revenue at point B, which is 120. So our total revenue, that should be TR. Total revenue is 120. So going from point A to point B, what happened to my price? Remember, price is over here on our y-axis. So what happened to our price going from A to B?
It went down.
It went down. What happened to our total revenue? Revenue is over here. What happened to our total revenue? It went down. So because our price and our total revenue go in the same direction, this is inelastic. Okay, they're directly related, they go the same direction. I could flip this and I could say from point B to point A, what happened to my price? It went up from B to A, if I'm increasing the price. From B to A, what happened to my total revenue? Going from B to A, what happened to my total revenue? It went up. Both of them go up, so therefore it's still inelastic. It doesn't matter if I'm increasing or decreasing the price. The price and the total revenue is going in the same direction, so therefore it's inelastic. Now, keep in mind that producers like to note this about their product. They want to know if their product is elastic or inelastic. So think about this. If they know, okay, this about their product, if you know your product is elastic and you drop your price and your total revenue is going to go up, what do you suppose you're going to do to your prices? Bring them down, because you're going to make more money, right? Okay. However, if you know your item, your product you're making is inelastic, and you drop your price and your total revenue is actually going to go down, what are you going to do to your prices? You're going to keep them the same, you're going to increase them, you're going to charge as much as you can because you know that they're going to buy this no matter what, right? So that's a thing that, is the importance of this. And we'll talk about some more applications of this later. All right, this is again continuing the total revenue test. The last point that I wanted to make with the total revenue test is going to be the unit elastic. So in unit elastic, the total revenue actually stays the same between the 2 points. And so this is what I meant when I said that there's nothing that is always unit elastic. There are points on a demand curve where it's unit elastic. This is what I'm talking about. Okay? You will find that there is kind of sections on a demand curve that are unit elastic. Now, I have a demand curve that I drew that is perfectly unit elastic, but like I said, nothing is always this way. So you're not going to really have the whole thing be unit elastic. So with this case, okay, when you draw it, what do you suppose if it was perfectly the entire curve, perfectly unit elastic? What do you suppose the curve is going to look like? It's going to be what? Horizontal. Okay, horizontal we had mostly horizontal. We had an elastic. Inelastic was mostly vertical. What do you suppose is going to be unit elastic?
Whatever this is.
Diagonal?
Yes.
Yes. So it's going to be a perfectly diagonal line. Okay? So this is generally what I draw whenever I draw a general demand curve. I draw a straight diagonal line. It does, it's like a 1-to-1 slope, right? And again, we're taking out 2 points on our demand curve. So we're picking out this point, point A. We're going to pick out this point, point B. And we're going to look at what happened to the price and the quantity as a result. So at point A, we're going to say again that our price is $25. And we're going to say at point A, our quantity is 8. Ooh, I changed the quantity. So 25 times 8 is, quick people with math. Total revenue is what? 200. Total revenue is 200. Again, should be TR. I need to switch my terminology. Okay, so TR is 200. Okay. At point B, our price is again going to be $20. And our quantity is going to be 10. So 20 times 10 is $200. Look at that. Total revenue stays the same. so therefore this is unit elastic. This one is really easy to tell, obviously. You don't have to remember anything about it. You just, you do the math and you're like, yeah, this is saying unit elastic. Okay, that's going to be really easy to determine. All right, so does anybody have any questions about how to do the total revenue test? We good? All right, as I mentioned last week, this is one way to determine elasticity. You do this if you actually have a demand curve. You actually have a demand curve, then you can use the total revenue test to determine the type of elasticity. But you don't always have a demand curve. Okay? You don't always have the numbers to be able to manipulate. So what you can do is you can do what I call the 3 questions test. And the 3 questions test is going to be really simple yes, no kind of questions to determine if something is elastic or inelastic. And it's only elastic or inelastic because, remember, nothing is always unit elastic. So the only way to determine unit elastic is with the total revenue test.